Good morning. We are now discussing the expectation values of dynamical quantities. We have already studied the significance of psi square is nothing but the probability of finding the particle in space. If that is in the sense the probability of finding the particle at any point. If we perform, or in other words, if we take a large number of measurements of finding the position of a particle in space, then the probability is given by the relative number of times we observe the particle in that given volume. Hence, it is possible in order to define the average value or the expected value of that particular function. As an example, we consider the one-dimensional case of the expectation value of position coordinate, and that is given by the expectation value of position coordinate x is given by the integral minus infinity to plus infinity psi star a function of x and t, x psi again function of x and t dx, and that will be equal to integral minus infinity to plus infinity psi star psi will be psi square, therefore it is x psi square dx. This gives the expectation value or the average value of finding the position of the particle along a line or along x-axis between the limits minus infinity to plus infinity, if we perform number of measurements along x-axis in order to find the position of the particle. Coming to the expectation value of momentum vector. Expectation value of momentum vector is equal to the integral psi star p psi dr. Dr gives the region of space. Then it becomes integral psi star p is an operator, momentum operator, and it is given by minus I h cross del of psi dr. That is equal to minus I h cross into integral psi star del psi dr, or p of x, that is momentum along x-axis only, that is in one dimension, is given by minus I h cross integral minus infinity to plus infinity psi star dou by dou x psi dx, and that will be the momentum or the expected value of momentum along x-axis. Now coming to the expectation value of potential energy. The expectation value of potential energy is given by the integral minus infinity to plus infinity psi star v psi into dr. So in all the three examples that we have studied, we have observed that the expectation value of any operator, is first expressed as a function of coordinates and time. As a function of, we have expressed it as a function of x and t, or as a function of r and t. So in order to do this, we assume the classical equations are true for the expectation values of the operator. Again, by considering the classical equation for energy, E equals p square by 2m plus v, where p is the momentum and v is the potential energy and m is mass of the particle. Now applying the expectation values for it, we get the expectation value of energy equals expectation value of p square by 2m plus expectation value of potential energy v. Now by applying Schrödinger equation, Schrödinger time dependent wave equation, we have E of psi equals p square by 2m psi plus v of psi. Or writing the operators for energy, momentum P, we get IH cross dou psi by dou t, that is equal to minus H cross square by 2m grad square psi plus V of psi. And this holds good for the expectation values of the terms in the equation, and therefore writing the expectation value of IH cross dou by dou t of psi, that is equal to expectation value of minus H cross square by 2m grad square of psi plus expectation value of V of psi. Now multiplying this equation by psi star on the LHS on the left side of both LHS and RHS, we get psi star of expectation value of IH cross dou by dou t of psi, that is equal to psi star of expectation value of minus H cross square by 2m into grad square psi plus psi star expectation value of V psi. And this is nothing but the expectation value of energy. This gives the expectation value of energy, this gives the expectation value of momentum, and this is the expectation value of potential energy. And again, the expectation value of momentum along x-axis is px is equal to minus IH cross to integral psi star dou psi by dou x into dv, or simply dx is enough over here, dx. And py is equal to minus IH cross integral psi star dou psi by dou y into dy is enough. Similarly, pz is equal to minus IH cross integral psi star dou psi by dou z into dz. So these are the expectation values. Thank you.